Hello, my name is Vikram Jirkare. I am a student of first year engineering at Vishwakarma Institute of Technology, Pune. Every day on my way to college, I see waste fires on the roadside. These are a major cause of pollution and respiratory problems for people in this locality. As an engineering student, I feel that one should have an empathetic approach towards the problems in the society and try to develop solutions to tackle them. Thus, I started exploring more about this problem. This led me to think that the first step of addressing this issue is to record and analyze the local air quality degradation due to waste fires.
नमस्कार, माझं नाव विक्रम जिरगाळे. मी कॉलेजिट विद्यार्थी आहे. पुण्यामध्ये VIT या कॉलेजमध्ये मी शिकतो आणि मी वेस्ट मॅनेजमेंट रिलेटेड प्रोजेक्ट करत आहे. ज्याच्यामध्ये मी वेस्ट फायर मॅपिंग असा माझा प्रोजेक्टचं एम आहे. तर आपण बघू शकता की माझ्या मागे सारसबागच्या जवळ एका पाईप लाईनच्या इथे लँडफिल आहे. छोटं इलिगल लँडफिल आहे. इथे कचरा टाकणं अलाउड नाही आहे, तरी टाकलं जातं आहे आणि त्याला मोठ्याली आग लागलेली आहे. ही आग मी बऱ्याचदा पाहिलेली आहे. माझ्याकडे त्याचे प्रूफ्स आहेत, फोटोज आहेत जिओ टॅग. आणि आज ही आग मी तुम्हाला लाईव्ह व्हिडिओवरही दाखवत आहे. आपण ही आग जवळून बघूया. जसं तुम्ही बघू शकता, खूप मोठ्या परिसरावर ही आग, खूप मोठ्या कचऱ्यालाही आग लागलेली आहे आणि याचा धूर खूप जास्त आहे. आणि माझ्या समोरच इथे सारसबागेच्या या आगीच्या समोरच अजून एक आग अशीच आहे. त्याचाही तुम्हाला मी व्हिडिओ दाखवतो.
The project I am working on has two parts: a hardware sensor module and a GIS mapping system. We designed the hardware module to measure pollutant levels near waste fires. The GIS waste mapping system will help us in gaining spatial insights about this data. These are the hardware components we have used in our project. The sensors we have used are a particulate matter 2.5 sensor, an MQ7 carbon monoxide sensor, an MQ135 AQI sensor which also detects CO2 levels, and an MQ4 methane gas sensor. The Arduino MKR0 board has been used as the microcontroller in our project. It also has built-in storage capacity. The ESP8266 Wi-Fi module has been used to establish IoT connectivity. The circuit shows the MKR0 board connected to the sensors and Wi-Fi module via jumper cables on a breadboard. The sensors can be extended outwards from the container as probes for data collection.
This is our first experiment. We are testing the waste fire pollution detection module here. As you can see, the probes of our module are out from the box, and this is a small waste fire we have ignited in a controlled environment. We are logging the data on a SD card mounted on the board, and the data can be seen here on the serial monitor as well. Date is 12th December 2023.
The sensor data for one of the experiments is displayed here. This experiment was carried out on 13th of January 2024, and the analysis showed that the city average AQI for this day was recorded 137. However, during the waste fire event, the AQI in that locality reached up to 193. A higher AQI means poorer air quality. The sensor module recorded a rise in CO2, CO, and PM2.5 levels. During this waste fire event, the air quality of this locality degraded by 40.88%. Along with the sensor data, we also recorded the experiment parameters like the duration of waste fire event, the waste volume, and more. The waste contents such as foliage, plastic, and rubber were also documented. We also studied some important environmental parameters such as wind speed, humidity, rainfall, etc. from meteorological datasets. All the observed waste fires were mapped and converted into a GIS dashboard. This was done using the QGIS open source GIS software. This is the first ever attempt to map waste fires for Pune city. The map in the image shows waste fires in Pune city which have been color coded according to their severity. We have calculated severity according to these three parameters: the frequency of occurrences of waste fire events, the population affected in an area, and the number of or amount of pollutants that have been emitted in such a waste fire occurrence. Moving ahead, we plan to incorporate relevant satellite data and crowdsourced images into a waste fire GIS dashboard of the city to gain further insights. These insights will be beneficial to the local governance bodies and citizen groups for addressing the waste fire issue in a more effective way. We plan to make this model a part of the free and open source hardware FOSH ecosystem, which can be replicated worldwide. I hope that this project can contribute to addressing the problem of waste fires in our society. I thank my family, friends and professors for their guidance and continued support throughout this journey.